Hi, I'm Dean Ripple, Group Leader of the Thermometer Group at the National Institute of Standards and Technology. Today I want to talk a little bit about alternatives to mercury thermometers. Before we talk about the alternatives, let's look at a mercury thermometer. Down here is the bulb of mercury. The nice thing about a mercury thermometer is most of the time, if there's a problem with the thermometer, you know it because you've broken it. It's also self-contained and requires no power. One of the problems with mercury thermometers is that regulations increasingly restrict the sale of these types of thermometers. Mercury is also a neurotoxin and an environmental hazard. For most applications of mercury thermometers, finding an alternative is very straightforward. There are a few applications related to standards where there's some special circumstances. For those cases, we refer you to the documentation that accompanies this video. Here's an example of a digital thermometer. It has three components. There's the readout with a digital indication. There's a probe that comes with it. And then inside the probe, there's a sensor. Here are three examples of sensors that would be inside a probe of this geometry. Each of these sensors is a resistance sensor. The resistance varies with temperature, and that's what the readout detects. Electronic thermometers cost more than mercury thermometers. On the other hand, they're easy to read and easy to automate. Often that gives you reduced cost of usage. Here's a readout that goes all the way to 1/1000th of a degree Celsius. All these digits can be misleading. Remember that just because it has this many digits doesn't mean that the probe together with the readout has the accuracy indicated by this last digit. Now I'll talk about the different types of alternatives we can use. There are several sensor types. Many of the sensor types are all packaged in the same metal sheath probe. But it's important to know what type of sensor your thermometer is based on. One common type is the platinum resistance thermometer. That's called PRT for short. It's often called resistance temperature detector, RTD as well. A platinum resistance thermometer with a digital readout is very close to being a universal replacement for many mercury thermometers. It has good accuracy and a good temperature range of use. The sensor at the tip of the probe is subject to damage if you hit it hard, if it's mechanically shocked. If that's a problem in your application, you can get PRT sensors that are made of thin films deposited on ceramics. Those are a good choice for harsh environments. Another type of sensor that also fits into a probe like this is a thermistor. A thermistor is a good choice in the temperature range from -20 to approximately 100 degrees Celsius, or about -4 degrees Fahrenheit to 212 degrees Fahrenheit. A third type of sensor is a thermocouple. A thermocouple is a very simple probe. It's just two wires joined at one point, the measuring junction. Thermocouples are special. You need to use special connectors with the right type to match the wire that you use. They're available as wires like this, but you can get thermocouples also mounted in metal sheaths. Thermocouples are very rugged. They're the most rugged sensor. Their uncertainties are often not as good as the PRTs or thermistors. Another common substitute for mercury thermometers is another type of glass thermometer. This time the bulb is filled with a non-toxic liquid down at the bottom. Organic liquid-filled thermometers are a good choice if your uncertainty requirements are modest, perhaps 0.5 degrees Celsius or 1 degree Fahrenheit. These are a good choice also if your temperature range is limited, between -100 to +100 degrees Celsius. You do have to watch on shipping about separation of the column. Let me talk now a little bit about good measurement practice. Number one, I've already talked about it, avoid shock. With the electronic thermometers, You don't want to drop them on the table or even worse, onto the floor. This readout has a removable probe. Often the readout and the probe are calibrated together. Unless you're absolutely certain that a probe is interchangeable with another probe, don't take the probe out and put a new one in. You'll get the wrong answer. In many of the thermometer types, it's also important to select the right type. For example, thermocouples come in many different types. If your readout is not selected to have the same type as the probe you're using, you'll also get the wrong answer. You want to be careful not to exceed the recommended temperature limits of the probe that you're using. You also want to check the performance of thermometers on a regular basis and have them calibrated regularly, or you can look at some of the methods we describe on the website accompanying this video. That's it. Thank you.